Good.
This meeting is being recorded.
So once again, welcome everyone. This is Mudasar, and today we are going ahead and talking about multi-leader replication topologies. Okay, let's get started. So what exactly are we looking at? A replication topology describes the communication paths along which writes are propagated from one node to another. If you have two leaders, like in the figure 5.7, just to quickly give you a snapshot of the figure 5.7, it should, yeah, this is figure 5.7. So these are the two leaders and two users, and they are pushing their changes, and the replication happens between the leaders. So this is the figure 5.7. And that's a reference. So if you have two leaders like the figure 5.7, there is only one plausible topology. Leader 1 must send all the of its writes to leader 2 and vice versa. More than two leaders, various different topologies are possible. Some examples given here is the circular topology, star topology, all-to-all topology. The most general topology is all-to-all. Interesting. Uh, in which every leader sends its writes to every other leader. However, more restricted topologies are used. For example, MySQL by default supports only a circular topology. Okay, it's only supporting circular topology in which each node receives writes from one node and forwards those writes plus any writes of its own to another node. Okay, so it's not like one to many kind of a spread of the information. It is more like one node goes to next node, and it's a chain kind of a thing in a circular manner. And forwards the writes, yeah. Another popular topology has the shape of a star. This is the star topology. One designated node forwards writes to all the other nodes. The star topology can be generalized to a tree. Okay. One designated node forwards writes to all the other nodes. Interesting. Interesting. So in this case, this is the designated node, I suppose, and this is sending to everyone. So this is actually like a one-to-many, the actual one-to-many kind of a situation, whereas all-to-all is like many-to-many, it seems. Not sure how it's getting managed here, but yeah, it's like
so
a
I think star
yeah.
is not good, right? Because if that middle one goes, then
Yes,
none of the information will flow, right? I don't think
correct.
so any for application we should prefer this, right?
I mean, depending on what we're going for, if it's something that is low availability, people can live with low availability, and replicas are in place. But yeah, uh, I mean, there are multiple factors. But if it's low availability, I don't know, maybe this could be used. But again, there should be some backup services in the background, as we saw, right? The election process and all those things that will bring things up. So again, it's all about the intent. If it's a low availability and consistent, I think this star topology would come into picture.
So all to all is a combination of both circular and star, right?
Yeah, it's like a mix of everything.
Yeah, it looks like
Like
that.
many to many. Not sure how it's keeping a track of things, but it's more like many to many relationship. Like every leader sending it to every other leader.
NC2
Right.
messages. Yeah.
Yeah.
Which one, the star topology or the
No, all
all
to
to all.
last? Okay.
Yeah, we were just wondering, like this is more like a one-to-many thing. Star topology where we have one and it's sending it to everyone, the single guy. Whereas here it's like everyone is sending it to each other, right? It's going. So this guy is sending to this guy, this guy, this guy, and this guy also sends it to this. So it's like many to many kind of a thing.
Yeah, everyone is connected to everyone.
Right.
And that's more tightly connected. Yeah. Star has that issue, right? The central one.
Central one, that if that fails, things will go, yeah.
Yeah.
But there is an advantage, right? Because central server will be nearer to all the three, right? I mean, compared to all to all. distance, right?
Well, the question is, yeah, that if you think it that way, that is fine, but it will always be a bottleneck. That
Yeah,
one.
definitely. Yeah.
Yeah.
But
Even
in all
circular has that issue.
bottle, okay, that if you delete the center. But in all to all also there will be many transfer of messages, right? I mean, NC
Yeah,
to
so it will.
that's right. Is it a
But,
correct?
why circular has a bottleneck?
Circular, not all to all. I'm saying.
No,
Circular
circular
is
has
only
the
one side,
bottleneck
no?
like one leader transfer to the another leader, and now that leader is down, so it will not pass this to the another leader.
Yeah.
Okay.
But all to all is somewhat similar to gossip protocol. Everybody is talking to everybody, right? So a lot of
It's
messages.
it's not exactly gossip. So here in all, it's n square problem, right?
N square, yeah. I mean, yeah. Every server at least 2 messages if it is, yes.
But in gossip is kind of optimization of that.
Yeah, and gossip is sluggish protocol, isn't it?
Yeah, it's slow, yes.
Yeah, because the way it reaches to each and everyone, it takes long time, and it's not very reliable that way. Maybe.
But that is how they keep health checkup, right? It's in leaderless, right? Gossip.
Mm-hmm. Yeah. Okay. In the circular topology, it looks to me more fragile than even the star, right? Because even if one of the server is down, the whole network will be down in circular. In topology,
Same in star.
but
Yeah.
but in the star, if either others are down, other than the center one, at least some part of the network is functioning.
Correct.
Yeah, that way circular also is there. Yeah.
No, if the corners are down, the rest of them can communicate, right? I mean, the vertices.
Yeah, but then it
are
is
down.
the same thing. Like a star also will do. Others will still communicate. Yeah.
Oh, yeah.
Circular. Sorry. Yeah, they will also still communicate. Yeah, makes sense.
So best is all to all.
So here basically it's more about the chance that if this guy goes down, then it's as good as the entire thing has gone down. Whereas the leaf nodes go down, at least the central leader is there to manage the show. Whereas in the circular topology, if the main initiating node goes down, obviously the rest of the things go down. But yeah, it's all pros and cons here.
So in circular, more or less, load is distributed, but in star, load is actually on the central
Right.
node has all the loads.
It has to be very much vertically scaled up to manage this. Cool.
And in all to all, it's definitely not n square, right? Like only one gets the initial right, and it just passes on to the other. Or even the other nodes also pass that right to other nodes.
I think everybody can communicate with everybody, right? In all to all. So I don't think so. At a time, only 2 will communicate because the arrow shows right. Everybody can connect with everybody, right?
Let's say.
So let's do this, guys. I think they have elaborated the topologies as ahead. So let's go through that. Maybe then you get a better idea. As I can see, they are talking about the all-to-all and the other topologies. So let's go ahead and check this out.
Did they give examples of the other, the star and the all-to-all topology? Who uses that?
Not really. It's just the starting. At least not here. That's what I'm saying. Yeah. So right, MySQL supports default circular topology in which each node receives the writes and one node forwards to the other, plus any writes of its own. Another popular topology is shape of a star. One designated node forwards the writes to all the other nodes. Star topology can be generalized like a tree. Now, in circular and star topologies, a write may need to pass through several nodes before it reaches all replicas. Therefore, nodes need to forward data changes they receive from other nodes. To To prevent infinite replication loops, each node is given a unique identifier, and in the application log, each write is tagged with the identifiers of all the nodes it has passed through. Okay, this is to know that there's a replication log where all the identifier IDs are being maintained so that the infinite replication loop doesn't happen. Right? When a node receives a data change that is tagged with its own identifier, that data change is ignored because the node knows that it has already been processed. So here is the interesting part, which I'm trying to understand. When it comes to that node, there it could be that it might have taken, this data, but then this node also started something of its own. So I think they will have to keep a track of change, right? Every change coming from every node. Maybe that's how they will try to avoid the replication, infinite replication looping thing.
So all these are for single leader, right?
Circular and star topology. So in this case of star, yeah, it's a single leader. Circular is more like a chain. Yeah. Okay. So once again, guys, anyone who has any issues or queries, please let us know. We will openly discuss and interact. Yeah, Rohit, go ahead. You had something to say? My net is down. I'm audible, guys.
You are audible.
Okay. Yeah, I feel like someone else is trying to say, but I don't say.
Basically, is it only one leader in star and in star, or multiple leaders? Because the heading says multi-leader replication. So basically, I think the central node is not a leader as such, but I mean, because here the topic is multi-leader replication, right?
Correct. Has to be multi-leaders.
So the central node must be something other than leader mostly, but yeah, looks like it's the main leader which has.
Yes. So yeah, I mean, these are all leaders basically. That's what they are trying to say. And then there are followers for every leader, which get the information accordingly. But the communication here is within among the leaders. So maybe that's why it's still a multi-leader topology.
Okay.
Cool. So when a node receives a data change, yeah. So okay, that is right. A problem with circular and star topologies is that if just one node fails, it can interrupt the flow of the replication messages between the other nodes, causing them to be unable to communicate until the node is fixed. The topology could be reconfigured to work around the failed node, but in most deployments, such reconfiguration would have to be done manually. The fault tolerance of a more densely connected topology, such as all-to-all, is better because it allows messages to travel along different paths, avoiding a single point of failure. That's the benefit it is highlighting for all-to-all. On the other hand, all-to-all topologies can have issues too. In particular, some network links may be faster than the others due to network congestion, for example, with the result that some replication messages may overtake others. So let's take this example. Client A is saying insert into data key value pair x comma 1. It goes here. It pushes to the leader 1, then it gets acknowledged. And then leader 1 is replicating it to everyone, like leader 2, leader 3. And leader 3 is then updating something and updating it leader 1, leader 2, then acknowledging. So it seems that this update sequentially reached late to leader 2. That's what has happened. So let's have a look. So in the figure 5.9, which we can see here, the client A inserts a row into the table on leader 1. Okay, client A is inserting a row here. This is the scenario. Client B updates that row on leader 3, and then again, client B is updating the same row for a different value. However, leader 2 may receive the writes in a different order. It may first receive the update, which is from its point of view is an update to a row that does not exist in the database, and only later receive the corresponding insert, which should have preceded the update. I hope everybody is getting the problem statement over here, that the update came before and later on the insert came. Right? That was a mismatch of the sequence.
Yeah, the ordering, right? Okay.
Yes. Okay. So that is what has happened here. So this is the problem of causality, similar to one that we saw in the consistent prefix reads on page 165. The update depends on the prior insert. So we need to make sure that all the nodes process the insert first and then the update. Simply attaching a timestamp to every write is not sufficient because clocks cannot be trusted to be sufficiently in sync to correctly order those events at leader 2. So clocks cannot be trusted. To order these events correctly, a technique called version vectors can be used, which we will discuss later in this particular page. However, conflict detection techniques are poorly implemented in many multi-leader application systems. For example, at the time of writing, PostgreSQL BDR does not provide causal ordering of the writes, and Tungsten Replicator for MySQL does not even try to detect conflicts. Okay, so this is interesting. That this particular tool does not even detect the conflicts. If you're using a system with multi-leader replication, it is worth being aware of these issues. Carefully read the documentation and thoroughly testing your database to ensure that it really does provide the guarantee you believe it to have. Okay, so it seems here we just start with basic topology types and give a brief about how they work. And then we saw about the infinite replication loop, where the replication log is being maintained for every node, every change. Then we saw the challenges with circular and topology, as we saw and we discussed before, that one node goes down, the rest of the nodes coming up is a challenge. It's more of a manual effort that we need to put there. And fault tolerance for more densely topology is better because it allows, and it's basically recommending your all-to-all because of its fault tolerance. But at the same time, it is highlighting the challenges with respect to sequencing, so-called consistent prefix reads, where we want to have the insert before and then the update rather than the other way around. Yep, that's the part for topologies. And then there's something called version vectors, which is going to be discussed later on. So let's wait and watch. Cool. Any questions, anyone? Moving
So
ahead.
if this causality dependency to resolve these ordering with the version vectors, will it be possible in this scenario? Because if your update is coming, so you are just going to ignore it. That is what it's saying. But then when you are actually going to converge it. Yeah, maybe. Yeah, so causal dependency, basically, whenever you have, it's like when you have a network split, right? Network partition. That part, at least I know about to some extent. So then because you go to the previous version vector and just find if there are some relationship with whatever you're getting the changes for, right? So then you can say it's causal dependent when the network again converges.
Basically conflict.
Right, sort of, but when it is delayed because the network has not been partitioned here, still you might have issues like this because of the the performance of each and every server. It might be different, or the latencies, whatever the way you say. So then you are not getting in the right order, but the network is not partitioned. So I don't know, because here it says if you receive an update first, then the insert, but then either you ignore the update, then you take that insert, but then you won't be able to update because you're not going to get another request from that leader, or maybe the other leader keeps on trying it.
Yeah, and we can buffer a message. Yeah, when replica receive a message which particular version, it will check if this version can be delivered, applied to the local state. Yeah, but if it cannot be delivered right now, it can buffer and wait for a while until the first message will arrive. Yeah.
Okay. So
Like
you have to
message
hold it. Okay.
in some message queue, right? Something like that.
Yeah, something like you to buffer message in order to wait before applying messages to local state. Yeah.
Okay.
So only once we write, then only we'll send acknowledgement to the client that the write has been accepted, right? Till then it will stay in the
I think in multi-master, as soon as master has written to local storage, it sent ACK to client. Please correct me if I'm wrong.
Yeah, that is what it shows in that diagram also. 3.9. It immediately returns back.
Okay, without even replicating it.
Right. So then the replication happens. But still buffering will have some overheads of bookkeeping, isn't it?
Yeah,
definitely.
Yeah.
Queues will have to- yes.
But interesting. At least we have some way to do it. Okay. Makes sense. Yeah. Thanks.
Or client will keep on retrying again and again, but I don't know. That's what
No, client not, but it's now leader to leader replication. Client is not involved at all because he just writes in one leader and is done. So now leader to leader replication has an issue, and then how it is handled. Yeah. But Nick says that we might have some messaging and other things to do. Yeah, but this at least, yeah. Yeah. Sure. Yeah.
So, yep, now we move ahead to the leaderless replication. Replication approaches we have discussed so far is a single leader or multi-leader replication based on the idea that a client sends a write request to one of the node, the leader, and the database system takes care of copying that write to the other replicas. A leader determines the order in which the write should be processed, and the followers apply the leader's writes in the same order. Some data storage systems take a different approach, abandoning the concept of a leader and allowing any replica to directly accept writes from the clients. Right? It's the whole idea of some of the earliest replicated data systems were leaderless, but the idea was mostly forgotten during the era of dominance of the relational databases. It once again became a fashionable architecture for databases after Amazon used it for its in-house Dynamo system. And then React, Cassandra, and Voldemort are open source databases with leaderless replication models inspired by Dynamo. So this kind of database is known as the Dynamo style. This is interesting. So this is not DynamoDB, right? When we say Dynamo.
Yeah, it's the Dynamo only, not the DynamoDB.
Yeah, earlier we used to think same.
Yeah, if you say DynamoDB, Praveen will speak up loudly then again.
Correct. Yeah.
Yes.
DynamoDB is slightly different, yeah.
But that's also a no SQL, right? DynamoDB.
Sorry.
Yes.
Yeah. Yes.
Okay, cool. In some leaderless implementations, the client directly sends its write to several replicas. Okay, the client directly several replicas. While in others, a coordinator node does this on the behalf of the client. However, unlike a leader database, that coordinator does not enforce a particular ordering of the writes, as we shall see. This difference in design has profound consequences for the way database is used. All right, so now we are entered into the I guess lead application is writing to the database when the node is down. Imagine you have three replicas. One of the replicas is currently unavailable. Perhaps it's important to install a system update. And in a leader-based configuration, if you want to continue processing writes, you may need to perform a failover. On the other hand, in a leaderless configuration, failover does not exist. Okay. Figure 5.10 shows what happens if the client 1234 sends the write to all the three replicas in parallel, and the two available replicas accept the write, but the unable replica misses it. Let's say that it's sufficient for 2 out of 3 replicas to acknowledge the write. After user 1234 has received 2 OK responses, we consider that the write to be successful. The client simply ignores the fact that one of the replicas missed the write. So this is the 1234 making a change. Node 3 is down. Node 1 and 2 are working and acknowledging user 1234. Quorum write, quorum read, and read repair. Okay, yeah, don't want to jump ahead, but yeah, this is the 1234 scenario. I hope everybody is getting it. If not, please do highlight. Now imagine that the unavailable node comes back online, right? And the clients start reading from it. Any writes that happened while the node was down are missing from the node. Thus, if you read from that node, you may get stale or outdated values. To solve that problem, when a client reads from the database, it doesn't just send its request to one replica. Read requests are also sent to several nodes in parallel. The client may get different responses from different nodes. That is the up-to-date value from one node and a stale value from another. Version numbers are used to determine which is the newer. So that is what is happening here. It's getting the old value because the read happened over here. Interesting. Okay.
Yeah, and the recent values are having the greater version numbers 7 and
yeah.
What
bothers me here is that if the replica was down and it is up, shouldn't it not be available for read till it gets updated data from the other nodes?
No, that's why they take a quorum, right? Based on the quorum, decide whether that value is recent or still, right?
And also that replica is not completely down. It is just down for some time and it comes back again.
Correct.
Transient outage, something like that.
Okay, so I'm just trying to understand. The request comes here. Okay, it gets the old me-old.jpg version 6. And obviously the read requests are going to other replicas also. And these two guys then get the 7th version. So they're sending it back over here. So will this kind of reprocess the UI and then show the new value in this case?
That happens
It's
in
like
the background, read repair, yeah. Sorry, go ahead, Shashank.
No, I'm saying 2 of the replicas will confirm. Out of 3, they have decided that at least 2 should confirm the same value, right? Then only they will take. And read repair will happen in the backend, as you mentioned.
Okay.
Well, not only 2. Anyone in the 3, whichever the version is greater, that will be the latest value, and it should be updated for all the other replicas with the read repair. That is what I understand.
I mean, that equation should be valid, right? N plus W should, what is that? I mean, read plus write should be greater than N, right?
No, but we
number of
already have a
replicas.
version which is greater. So you'll always say that whichever version is greater will be the latest value.
So, but how do you know? Like that would be the. I mean, out of 3 replicas, if one says 7, others say 6, others say 5, or 2
7 is
says 6 and 1
the
is
7 is the
7.
latest value, no? So maybe
Yeah,
the
latest
read
value.
repair is not happening.
But then, what is the use of quorum then?
Quorum is for replication factor. You have to replica whenever you are writing. You write to one all those 3 replicas.
So whatever example Shashank was saying, there's 765. That's not a valid example. There is no read quorum happen here.
No, read quorum in this, out of 3 replicas, right? One node fails. Now client sends a request, right? And out of the 3, if 2 confirms that this is the value, then that value will only be returned to the user, right?
Yes.
That is quorum, right? And Santosh is mentioning now the node which has failed is having the stale value, right? So the
Yeah.
version which is having highest number, that will be replicated to the when it comes back, right? I mean, the
Yes.
failed node,
Mhm.
correct?
Yeah.
So, yeah.
Yeah, so Dynamo
I mean,
looks for
the
that.
latest will be always, I mean, whatever was succeed last time.
The highest, which will be denoted by highest number, right? Highest
Yeah.
version. I mean,
Mhm.
okay.
Yeah, so
so
there is slight difference between the Dynamo and Cassandra. Cassandra has tuning 1 also, right? So you can go to even if only single replica is present, you keep on writing to it. So at the end you can actually find out, whatever the way you can resolve it.
Oh, based on the recording, any exactly at most something like that.
Right. Yeah.
So I'll try to break things up one by one. So when the request is coming here in the leader list, when it says it is sending to all the replicas, so does it keep a count of bare minimum to hit the replicas, or it must be keeping a bare minimum count, right? That okay, only hit 2 replicas or 3 replicas for reading purposes. Right?
Yeah, it has that consistent hashing way of doing it. So it will have a first prime coordinator node in some cases, and then it will actually go to the next 2 in this in that ring. So
Yeah,
that will be
correct.
those 2, yeah, based on the replication factor. Yeah.
Yeah. So okay, so you're saying the replication factor decides, no, replication factor would decide the replication, right? Here I'm referring to the reads. So when the read is happening, so there are 10 reads. So there are 10 replicas. So when the read is happening, does it go read all the 10 replicas, or does it read only few replicas?
It depends on how much your replication factor is. Yeah.
Okay,
Correct.
okay, that's decided by the replication factor. Okay, okay. I was
No,
thinking that replication
not the
factor.
replication factor. Depends on that how do you configure that. So
There has to be some.
if you read your read count is that, I mean, any less than n by 2 or equal, then there is a chance that you may read the stall value, not the up-to-date value.
Yeah, so out of 3, n by 2 will be more than 2 or equal to 2, right? So if
Yeah.
2 of
So
them
if
returns,
you want to read the latest value, so your read should be greater than n by 2.
Okay. I'm sorry, but I think I'm not even. I think I'm not aware of the n by 2 thing. Is it like number of nodes, replicas?
Number of. Okay, so start with the start trying to understand this diagram. So let's say first you have to write something. Okay, client send a write request, and for each key you have 3 replicas.
Right.
So in that way you have to write. You will send your request to all these 3 replicas. Write request.
Right. Right has to go to all the replicas.
Now depend on your configuration. Let's say you say that, okay, if any one of at least n by 2 should write, and wait for a minute. It could be possible that you may not understand why it should be n by greater than n by 2.
Okay, so
So
here
if
the
it's
n
greater than
is
n by 2, so at least out of these 3 replica, if your n is 3, then you will wait for at least 2 replica should actually reply you succeed,
okay.
right? So now when you go for a read and you want to read the latest value, if you just say that, okay, I'm okay to read from one replica, and unfortunately you ended up reading from the replica which was not succeeded.
So we get a stale value most likely, or
Yes,
might not get
but
a value.
if you say that, okay, I will read from at least n by 2 node, so there will be there will be definitely at least one replica from where you will read the latest value.
Okay. So essentially, what you're trying to say is half of the replicas, the read and
No,
write
no,
is
more than half of the replicas.
more than half, right? Greater than n by 2, what you say. So more
Yes.
than half of the replicas, if the read and write is happening, that brings a consistency in terms of the writes or reads, at least in the reading part, where you make sure that if there is a stale one, like this case, it will read the 7th value. Because here, at least it will take the acknowledgement of two nodes to go ahead at this point.
Yeah.
Yeah, I have a question, but what if we have one more client and this client want to send a write request to replica, to 3 replica, but he was able to send just to replica 1 and failed. Yeah, so replica 1 has a version 8 now. Yeah, but client failed. It was not able to write to all replica. Yeah. But what should we return? What should we return for read request now? Because replica 1 has a version 8, replica 2 has a version 7, and replica 3 has a version 6. Yeah. What should we return? But
yeah, my understanding that in that case your read will fail until this has been fixed.
oh, okay, yeah, interesting. Yeah.
But I
Because
think,
the read quorum will not happen.
Yeah.
But there are 2 ways. No, Cassandra actually still permits based on the tuning consistency. You can configure it.
No, it will not. Whatever the scenario Nick was mentioning. So I don't know how it will happen, but let's say somehow all 3 replica has different version, latest version. And now your read quorum is n by 2 plus.
Yeah, but in that case, you are at least trying to be a better consistency, but in some cases, you can still have a consistency with only single node also. That is what Cassandra gives you a way
No,
to tune it.
then you will have to configure your read to get satisfied from one node only. But if you are you said that, okay, you will read from n by 2 plus node and then succeed only. So in that way, I believe it will fail.
Yeah, but there is that way to configure it. But then again, it gives I think the user that flexibility.
So Cassandra, I mean, if you're writing it, I mean, if the replication factor is 3, even if it has succeeded in only 1 and it has failed 2, it will give you error, but it won't revert the value in the one in the already say succeeded replica.
Yeah, I think that's the drawback for all these leaderless.
Yeah. So they started and they've introduced this one lightweight transactions or something they call it. That they do it with the consensus kind of thing, raft or package.
Okay, so you are saying that, okay, first they push the value to all these nodes, and that is part of this lightweight transaction, and when they push the value, then they actually send the commit command.
Yeah. But it will be much more latency than what was earlier.
Yeah, that's fine. Because NoSQL, we don't. I mean, generally we use NoSQL where latency is not much of that important, right?
Latency is important.
This is important.
The other way.
Everywhere is important, or else the user will get frustrated. Yeah, but
True,
this is
but not.
complex topic, no? Yeah, that is right. But it depends on the use case, what you're looking for.
Sorry, Uday, I did not get. If we have 3 different versions, what Cassandra will return?
So if it has 3 different versions, it will give the latest. I mean, the version which is the most recent one based on the timestamp.
No, but
Okay,
if read quorum is n/2 plus.
Sorry, I may not have understood the question then.
So the
So-
read quorum is n/2, then surely it will fail. But if the read is, you can still have you can have 1, 2, 3 specific also, or n/2, and many of them. Like even you can have n, so for a strong consistency. So they have the different ways to tune it. At least that is what I read from the grogging advance. Maybe I can open it.
Yeah, that is the case. Like tunable consistency, Cassandra has, right? If you
Right.
want strong consistency, then make all the nodes right. If you want, I mean, slight lesser, you specify how many read, how many write.
Yeah, because that at the time also when we were discussing, we had that similar confusion. So because it
Correct.
doesn't really gel well, so okay, consistency, yeah. If
I think I got. Cassandra does not use version vector. Cassandra rely on timestamp. Yeah,
last
and
statements, right? Yeah.
yeah, and so in each write request, yeah, we will have different timestamp at each replica. Yeah, there will be, how to put it, sorry, in English, the version will not be the same because it's timestamp. Yeah, it timestamp has a different value at different node, and Cassandra has to return the latest one. Yeah. Because it will never have a same version at a different node because of time drift.
Yeah, so I think this is the one what I'm talking about that Cassandra has. When it talks about all the right consistency levels. So you have a similar for a read also. So you can have 1, 2, or 3 also. You can specify replica nodes like that, or you can have a quorum, what we discussed about replication factor divided by 2 plus 1, or you can have a strong like all, or you can have something like local. I think it is for the same data center. Then you can have each quorum. It ensures that the data is written to quorum of the nodes, and then you have any. Any means any one of them. So then actually it comes with that hinted and of and all that. So I think there is something to do with the read consistency level also somewhere. Yeah. So I think maybe I took it from some other paper. But yeah, so this is what actually it talks about. I think it is at the bottom. If you go for the read, so this comes here, then you have that. Okay, he looks for the snitch here, right? Okay. Yeah.
Snitch is searching the nearest coordinator node, I think,
Right,
if I
yeah.
remember.
So the read consistency level is less than all and all that. So again, the same thing it comes for that read also. But then the repair is again different ways for each of them.
What Nikolai has said is might be, I mean, Nikolai is talking about the time, right? You are talking about the clock diff, but that might happen in MySQL or the RDMS kind of cases as well. I'm thinking the coordinator might be deciding the timestamp and forwarding it to the replicas rather than each replica taking its own local time. I'm thinking so, not sure.
I think that makes sense what you said, Uday. In that way, because if each replica will decide, so there may be some difference in these timestamp.
Yeah, you say that Cassandra has same consistency level for read request as that of write, except the each quorum because it is expensive. So both of those their consistency to enable consistency apply for read as well as write. Yeah, but there are a lot many things to go in this also. Yeah.
So basically in three, I mean, I didn't get the answer for that still. Like, so if three, what do you say, three replicas are there and all the three has different values, right? Then the most recent would be written, right?
So
Given
it depends
that
on how you are actually selecting your tunable consistency. So if it's a
it is
quorum based, then it will go the way we are discussing. It has to get for the 2, right? If it's n by 2. So if it is
otherwise,
3, yeah, then you will still look for 2 values. If you select the quorum, if you select only single one, then you will go, yeah. If you select any, then anything should be fine.
because you don't, either of them satisfies you. Yeah.
Yeah. Okay. I think let's restrict to quorum only here because we are discussing about that, right? Yeah.
Correct.
So yeah, right. So we're basically talking about this part where the stale data comes into picture. To solve this problem, it doesn't just send its client to one replica. The read requests to several nodes in parallel. The client maybe get different responses of different nodes. The updated value from one node and stale value another. And in that case, the version numbers would be used to determine the latest value. Cool. Moving further, read, repair, and anti-entropy. The replication scheme should ensure that eventually all the data is copied to every replica. After an unavailable node comes back online, how does it catch up on the writes that it missed? There are two mechanisms often used in the Dynamo Style data stores. One is the read repair. When a client makes a read from several nodes in parallel, it can detect any stale response. For example, user 2345 gets a version 6 from replica 3 and version 7 from replica 1 and 2. The client sees that the replica 3 has a stale value and writes the newer value back to that replica. It's happening during the read. This approach works well for values that are frequently read. This is for that purpose. Okay, then there's the anti-entropy process. In addition, some data stores have a background process that constantly looks for difference in the data between replicas and the copies. Interesting. Any missing data from one replica to another. Unlike the replication log in leader-based replication, this anti-entropy process does not copy writes in any particular order, and there may be a significant delay before the data is copied. Okay, it does not copy it doesn't copy in any order and runs in the background, right? That's what the whole deal is. Okay.
So this is the same which it uses in Merkle trees, right? The anti-entropy process.
Merkle Trees, yes.
That is the way actually it brings that particular replica.
Merkle Trees like comparing the hashes, right?
Yeah, it compares actually the blocks, so it creates hashes of certain blocks and then it forms a tree. And then when it is trying to compare which portion of the particular replica is not in sync with the other one, it does based on the tree structure. Like we have a segment tree or maybe something like that to compare, right? So similar structure.
Leaves get compared and I think if they are saying they get merged to the root, right? Something like that.
Yeah, because the root will always have two hashes, one hash. And if both the hashes of the root are same, then it means the replica is synced. If it is not, then it goes to either of those below ones, and tries to find out whichever one is not inconsistent. So only
Inside
that
the-
particular block is copied. Yeah.
So why anti-entropy? Entropy is randomness, right? So anti-entropy, that term I didn't get why it fits for that Merkle trees.
Anti-entropy, I think it's against the what time or
Randomness.
temperature. Yeah.
Yeah. Entropy is that only. When you increase the temperature, movement of molecules increase, right?
Mhm.
Yeah, it's measure
get-
of chaos. Yeah, I don't know how to put in English.
How randomness that particular thing or whatever, right? Measures the randomness of anything, I think. Entropy.
Yeah, by the way, what is the difference between segment tree and Merkle tree?
For me, because the Merkle tree actually is based on the hash values. Okay, segment tree actually we try to get we have different properties in the segment tree, right? Either it's a max value or maybe the sum of the particular root, a subtree, something like that. But here it is the hash values. Merkle tree is fixed, it's only for hashing. So whatever the leaves we have, we take a hash of that particular data in the leaf, and then we keep on going up the parents one by one, and then keep doing the hashes of the previous subtrees.
Okay, but if we use hash in segment tree, yeah, and let's say do sum of hashes, it will look the same, yeah, will not it?
Yeah, I think so. Therefore, I was trying to relate that.
Yeah,
They
thank you.
specifically always talk about Merkle tree when they talk, they say Merkle tree. They don't talk about segment tree. So I was just trying to relate that. Yeah. It looks like that, yeah. But any binary tree also should work, right? But the value in the parents will always be different. Inner nodes, basically. Yeah. Oh, sorry, yeah. Mudsar, go ahead.
Yeah,
That's
that's
right.
fine. That's fine.
It should be converted.
What is that, Hishan?
No, I'm saying in normal binary tree, even if we compare the hashes of two leaves and put it into the root, that will also work as Merkle tree, right?
Looks like, yeah. It makes.
I'm not suggesting
But
it's
maybe they have some different more things to it. It's not that because they would have said, right, everywhere it's similar to symmetry or binary, but they are not saying it. They are always referring to Merkle tree. Maybe we need to look at that paper also something. There might be
Some
more
special
things actually, yeah.
The Merkle tree is discussed in DDIA itself, I think. What they call it.
Yeah.
Yeah, I can start.
So, yep, good approaches that we discussed, and I believe this is what it is: read and repair and anti-entropy process, where the background process running, and copying the, checking the versions, and I guess doing some updates. Not all systems implement both of these. For example, Voldemort currently does not have an anti-entropy process. Note that without an anti-entropy process, values that are rarely read may be missing from some replicas and thus have reduced durability because read repair is only performed when a value is read by the application. So essentially, if it's not anti-entropy, then obviously the repair has to be there, right? I believe that's what it is trying to say.
Well, see, read repair will always be there. See, whenever you read, you will always repair it, right? But say in some cases, if you have problems with the write and your read doesn't go to that particular record, right? So your values will not be repaired at all for those replicas, right? So then how do you resolve that? In certain time, then you have to use this way. When you see there is a lot of divergence between two replicas, then this is the best way to do it.
So both of them.
Both of them are
could be,
required,
yeah.
right? Yeah. That is what at least I think, because it makes sense, right? So read repair does it very quickly, because if you write it and then read it, it's fine. If you don't read it for maybe long number of time, and then if you try to compare those two replicas, they are very divergent because many of the writes might have read repair remaining, right? So someone has to converge it. So this is one way.
Yeah.
Read repair happens for stale replicas only, right? I mean, updating that with the current value.
Right, correct. Yeah, that is what I actually, yeah. In the quorum, right? If one of the replica is blagging, So immediately
yeah.
when it comes back, because of that GC pause or something they call, it actually holds that replica. It's not actually down, but it holds the replica because it's not responding. And then actually it comes back again. So then what to do? It's better to, if you get another read, then you at least repair that one, right?
Correct. Update with the latest value something.
Yeah.
Correct. And that's why it's telling here that not all the systems have both of them. Like for Automat over here, it doesn't have the anti-entropy process. It purely relies on the read repair to have the updates. Thus, they have reduced durability. So why would you even have reduced durability? But eventually, during the read, that fix will be done, right?
Yeah, but if you see the next statement, because the read repair is only performed when a value is read by the application. So if your application doesn't read it, then you will always have that value incorrect in some replicas. But the replicas which have the correct values, if they are, if they fail, so then there will be a problem, right? And then maybe the written values are all maybe even destroyed forever for some or the other reason. If some replicas have only the latest values, because there will be all these valid values will be distributed across replicas, and one replica might have the best version of the right version of it, and goes down forever. So then durability is a concern there, right? In a worst case scenario, you might lose some data.
Things, yeah.
Okay, so I guess the next one is a pretty big one. I think that's where we'll talk about the read, right? And notes. So we can start this fresh tomorrow. Hopefully, address quorum.
Yeah, if let me ask a question. I have a question about Cassandra. Does Cassandra provide atomacy of write request? As we discussed it, client can write just to one of node, yeah, and fail it. Will the value be deleted somehow from this node because it was not written to quorum, yeah, but just to one?
So you are saying if we select that consistency level in Cassandra, right? Consistency level of a single node.
No, not a single quorum.
You are saying a quorum.
Yeah, quorum, but I failed. Client failed. Client was able to write just to one node.
But see, usually we have that consistent hashing ring, isn't it? So usually the way I think we have been reading Cassandra is like it will have a coordinator node, and then if we have that quorum size of 3, so it will go and write to its next two replicas, right? But if those replicas also fail, then it has to go in the ring to the next two replicas. So it keeps doing that till it has only one replica remaining. So,
but what if coordinator failed? Yeah, coordinator was able to write just to one node and coordinator failed.
Coordinator fails, then you actually, if you say you write to coordinator, it was present at that time, and then it fails, right?
Yeah, but coordinator was able to write just to one of node.
Well, okay,
and
see,
failed.
it's not like that. See, what happens is whenever you're writing, you write in parallel. Whenever you're, even if you're writing to coordinator at the same time, it writes to other two replica, all the three replicas in parallel. So if coordinator node is always assigned based on that hashing value, but if it doesn't, if you don't find a coordinator node, you have to find another node to, like that hinted hand of wave, to actually do that. But you are saying coordinator node was there and it failed, but your write process is always in parallel, so it will at least go to other two replicas, but you are saying those also fail, isn't it?
Yeah, but one of replica was able to write, but another two was not able for some reason.
So there we use some, the nodes share their states also among themselves, right? So you are saying if one of them, the data was written to only one replica, right? after every seconds, I think, or whatever the time gap, they share their states with each other. So subsequently that data will be transferred, right?
Yeah, but the coordinator, if it fails and when it writes and fails, then will that request will return an error, right?
Yeah,
It
technology,
should
I guess
return.
it will return there.
I
Because that is
think
not
so.
written to required number of nodes, right?
Yeah, and also like if the coordinator fails, then who returns the request back? It won't return, right? It will time out.
Yeah.
Okay. I think Praveen was saying something. Sorry, Praveen, go ahead.
No, I just wanted to, I mean, as you guys already discussed that whatever scenario Nick was trying to simulate here. uh, My take is that it's a implementation, how you implement that, these kind of thing in your system. And you're talking about the Cassandra. So as Uday mentioned that without transaction, that's not possible, right? And Uday mentioned that they started this lightweight transaction. I don't know how it worked, how they implemented it. But yeah, if transaction is there, not sure whether it will solve that problem or not. But without transaction, I read somewhere in this book, and whatever I'm saying that's pure theoretical based on my reading. Yeah, if some node that request is partially succeed on some node and failed on some node, so there's no way to roll back those succeeded value from those nodes.
But does Cassandra do that rolling back? I doubt.
I don't think so. But
will be difficult even to roll
Uday
back.
may chime on that. If it's fail on some node, do they actually reward the value or?
Yeah, because based on the consistent hashing, if those two replicas in the ring, which are also failing, then it has to go to the next replicas, right? So it's very hard to roll back in all the replicas.
Yeah, and I don't know what benefit we will get to roll back these values.
Yeah, so those designs are actually theoretically very nice, but implementation looks not so straightforward, right?
Terrible, yes.
Yeah, it's not that easy to maintain that.
Cool. Yeah, thank you.